And we are live with our 107th episode of Absolute AppSec. I'm Ken Johnson at CK Tricky on Twitter, joined by my co-host, Seth Law at Seth Law on Twitter. Seth, say hi.
Hey, everybody. Welcome back to another episode. We talked about logging and monitoring last week, but this week we're excited to have Markus on because all we're going to do is bag on Ruby all episode long. No, we're going to talk about why Ruby is difficult, I guess is really what it boils down to. I mean, there's good things, there's bad things about every language. Markus is an expert around that. We'll get to his background in a minute. Outside of that, we are planning a follow-up to Midsummer Nights Con this winter with a similar group. So watch for that. We still haven't quite nailed down the exact dates for it, but it'll be sometime in the middle of the winter, right? Around winter solstice. That's going to be the plan anyway. And outside of that, we've got some training coming up. Watch our Twitter feeds, watch AppSec.com. The rest of that will pop up from there. And please feel free to jump into the conversation, whether on Slack. The link to our Slack channel is on our website, or just DM us, or even jump on the YouTube page and comment there. If you've got any questions about what we're talking about or what we've talked about in the past, please do so. Ken, I don't think we've got anything else right now. Any announcements that I'm missing, or you feel like we should bring up that I forgot about?
No, nothing. I don't think there's anything that you forgot. Not at all. So I can introduce Markus. I don't know if we should go right into it or what.
Yeah, I mean, the only other thing from a news perspective, right, this last week there was that Slack RCE. I don't know if you want to talk about the bug bounty a little bit before we dive into Ruby and what's happened there. Are you familiar with that, Ken?
So I don't really here. I've only caught, because this all just happened, I think, like Friday. The only thing these are the only details I know. It wasn't like, I think the payout was lower than some people expected, but then I'd heard, I haven't looked into the details at all. I just heard that RC was like, you needed, I think there was something missing to be weaponized. That's all I can remember. And that might've been why the price was lower.
I've just skimmed it, and it seemed to me it's like there was a very delicate chain of user interaction, but I'm not sure if that was the reason for the lower payout or not. I've not looked at the details.
Yeah, I mean, from a researcher perspective, I mean, that's the report from HackerOne. You can go read through it. I mean, it's XSS, but the problem is Slack is an Electron application, so it runs inside of, it's basically Node running on your desktop inside of a container. So XSS is the equivalent of code execution, right? So remote code execution. But from a researcher perspective, I have a really hard time with, hey, this is RCE, this is a critical vulnerability, and maybe it does line up, and Slack only pays $1,500 or whatever for critical vulnerabilities. But this is the sort of thing that could have been turned into this great Trojan horse that would have taken down. I mean, let's be honest, most of the security industry, or a lot of industries for a long time, had they been able to inject something in there, right? So the payout doesn't reflect the risk to Slack or to the customers. And I think that's where the big discussion point jumps, right? Is everybody's like, really? You only paid out, $1,500 for something that would have been egg on your face, would have been reported all over the news. It just seems like your reputation is worth more than that. I mean, Ken, I know you guys at GitHub, for a critical, you're going to pay out more than that, right? If somebody found RCE and GitHub Enterprise, that would be huge. Am I not right? And I said that right as you took a bite. Sorry.
No, that's cool. Yeah, no, I was just trying to sneak in a stack. It would probably be in the range of, I mean, don't quote me on this, but I think 15 to 20,000 is the average for a critical.
Yeah,
for us, for our program. I mean, it's actually public, our pricing and how that all works. But yeah, RCs are
So the problem with all pricing is that someone has to assign the specific vulnerability to the pricing slot you define. So, and if that assignment is wrong, it doesn't matter if there is a higher pricing slot available. So, and I think the bigger problem is not the payout in itself, but how to classify into the pre-assigned payout tiers you might have. That's a bigger problem. And
it speaks to kind of the triage of those findings, right? And how Slack, I mean, whatever team it is that's triaging what's coming in from the bug bounty, how it's getting classified. I mean, I know those conversations that I'm in, we have a tendency to, assume the worst and then convince ourselves that the worst, is there a path to make it to that worst case scenario? Because if there is, then it justifies a higher payout. If there's no path to it, then there's not.
Yeah, but the path might not be known. So what this vulnerability was could be a path of an exploit chain. And the other small bug, which could make this bug really, really, really bad, just is not found right now.
Yeah.
So, and that's a problem I always have with these kinds of discussions, because you can always turn any line of code which introduces a vulnerability into a real vulnerability, given something other unknown happens.
Yeah.
And to then classify, and you can chain 10 small bugs and have a perfect RCE. And why wouldn't a part be worth less? Because every single part, if it wouldn't exist, might kill this chain. So it's really hard for me to decide, okay, this is just an XSS, but maybe this XSS could be part of an RCE later on. So it's a real one, which would have rewarded a higher payout. So it's really hard to just tell, okay, so there was researchers submitting a vulnerability, and it's not a full RCE with a big payout, but he just didn't put in the time to find the full RCE. Maybe it will be activated with the next release. The next release has a bug which turns it into one. So it's more like a lottery if you get the full payout, because the current state of the system allowed to justify the bigger payout. But this is a function over time. It's not like the snapshot. Okay, I submit this vulnerability, and it's worth a lower amount right now, but tomorrow it could be worth 10 times more because there are other bugs found. So it's really hard for me. I couldn't point to a better system. I can only point to the problem here.
Yeah.
Yeah. So I just want to back up here for a second too. I think that there's one thing because I had not looked into this at all. I just kind of did a brief skim. So correct me if I'm wrong. I'm going to just speak to this at a high level. There's a payload. You execute the payload as the victim. In your Slack instance, that RC is an RC on your machine, not on like Slack.com, right?
Yes. Yep.
All right.
Yep.
Okay. So in that case, this is different because for us, so I want to back up because this uses Electron, right? Which is like the main way that these desktop client apps work. And Electron itself, there's a lot you have to use it out of the box. Basically they leave all of the configuration up to you when it comes to security. There's a lot of things that this is a common thing. So, but however, this is a little bit different because you had asked Seth, what about like a GitHub or an RC in GitHub Enterprise? Sure, that would be an issue, but this is not the same thing, is my point. This is a client running on your machine, and that totally sucks if your machine gets RC'd. However, there's a few chained steps, and this is not something that is like uncommon that happens to Electron apps. It's actually very common. We have this happen occasionally with Atom. We don't even triage that. We send that off to that team. They can handle that, right? So I guess what I'm saying is like, there's a few factors here. One, this is not an RCE of Slack.com. Yeah. Different. There's no mass exfiltration of user data. The steps take quite a few steps, but although it's not impossible to execute this or anything like that, but the impact is, whoever's you share a Slack channel with might be able to do this to you or was able to do this to you. But I just think that it's not some like everybody's data got pwned type deal. That's not the same thing. It's not the same thing at all. So I can see why they didn't go with the critical call on this. And even though that sounds crazy, like shouldn't RCE be, but man, really, I don't think so. Not on your Slack instance or your Slack app running on your machine.
Yeah.
The problem is if you hit a developer machine, you by definition hit the developer's credentials, and most developers, frankly, frankly speaking, have a really bad hygiene. So they do not separate clients from each other. If you talk about freelancers, they do not separate development environments from production environment access. It's all in some env variables which you have to set prior running to. So most developers are like dirty pigs in that area. So if you argue, okay, so
are security people. We all have.
So
security tools are some of the worst. And in terms of stored threads,
the problem is now, this is just a small step. So you could have weaponized this to target some developers and maybe even Slack developers themselves, and then from there stepstone to target Slack.org. So that's a problem I have right now, because if you assign a criticality level to a small thing like this, okay, arguably smaller than direct exploitation of Slack.com, how do you know it couldn't be used with something unknown together to get you to a full exploitation?
Yeah. Right. And so this is dangerous. This is what I want to say. This is dangerous. I certainly personally think it's worth far more than $1,750. I don't think what I said before communicated that. I do think I think that this was a low payout. I think that the risk is higher, but I wanted to just point out for us at GitHub, when we call something critical, that's the highest tier that we can have. What that means is you can send a payload to my machine and to my website, and immediately you've got access to those systems, and you can pivot throughout my network, possibly access the data of other users. It's a scary, scary thing, and it doesn't require user interaction. We're talking about critical as in we left something open and this is bad. Now, I don't think that this falls into critical. And I don't think it falls into critical because I don't think it's a mass exploitation of user data or infrastructure that holds a ton of user data. But I do think it's dangerous. That's what I just want to say there.
I'm curious. Because I could argue either way, right? To be honest with you, because this is Slack's core business functionality. The fact that any Slack that I'm in, so the way that I read it is I can get RCE on anyone else that is connected to that same Slack instance that's running the Electron app. They're not inside of the browser, which is the majority of people. So at that point, I'm like, yes, right?
Do you even need RCE to Slack.org if you have all the people already?
Yeah, exactly. Because you've got all the clients there. And again, I kind of go back to that Trojan horse idea, right? If I really wanted to, Bitcoin mining or whatever else you want to talk about there. But at the very least, I could do some huge denial of service and just start every Slack channel that I'm in. I'm starting to send this out to everybody and crash all those systems and cause Slack to have all sorts of. So there's the reputational risk there is what kind of raises the bar for me, as opposed to just the RCE by itself. I mean, I think about Twitter, and I think about TweetDeck and that XSS that went through there, it's kind of a similar thing. Yes, you're not necessarily attacking Twitter at that point, but you're attacking all of these clients around it, and you're causing the issues with them. So I mean, it walks a fine line for me as well, I guess is what I'm saying. And that's why, like, just us having this discussion, right, warrants more of a payout in my mind than what was attached to it.
I had an interesting thought about how to value payouts. You have to argue, so what if this one wasn't found via HackerOne, but active exploitation by a state actor, and what would be the market value drop of the company? That should determine the payout. Obviously, you do not give them the full market value drop, but it should be proportional to that one, which is also hard to estimate, but we need to set some boundaries here. So lower bounds and higher bounds. So, and if you, as a researcher, put in the full work, it should be, but it didn't happen. So we do not know what the market value drop is, and Slack is public, I do not know. It's just another way to value these things. You just go for economic damage and then a fraction of that.
Yep. Yeah. Well, anyway, I don't think we're necessarily going to solve this one today, right?
Very unlikely. We can only put in some constraints on a possible solution.
Yeah, exactly. And I think it just goes back to the whole, you really have to have discussions around this internally with your team on what the real risk is associated with it. And even, to the researcher community as well, how what sort of message it sends to them about the vulnerabilities and digging into your program, right? Especially the public programs. I know certain public programs have great reputations, other have very poor ones because of the response and because of how serious the team takes the vulnerabilities when they pop in. So.
Man, another thing that I don't think that was even discussed is I was reading the thread and like I think that there's multiple reasons why this researcher is probably, I'm assuming the researcher's not happy. I don't know I honestly wasn't paying attention to any of this, but assuming the researcher's not happy, I see why. So their engineering team, it looks like, didn't talk to the Slack's engineering team. It looks like they didn't talk to the security team. This researcher waited months and months and months and wanted to disclose this. They told the researcher to hold off. However, Slack's engineering team went and then posted a blog post about their like fix and the situation. They didn't mention the researcher. They didn't mention the RCE, like the write-up for this RCE. So the like interim CSO over there at Slack had to step in and apologize sincerely to the bounty researcher and say, look, there was a misstep. We didn't communicate internally. That's our fault. Engineering wasn't supposed to release that with like, this is a mistake. And they were trying to like, I honestly think they were trying to like, oh crap, this is just, mistakes happen, miscommunication happens. But I can see why someone would be upset in that situation. So for what it's worth.
Yeah. I didn't get down into all those comments. I'm looking at it now, but yeah, that in and of itself is a pretty big mistake.
Yeah, with it being a sub $2,000 payout, with that misstep, it taking months and months, like I can see why anybody would be kind of like, I'd not be happy either. So, yeah. But we should introduce Markus. We should get into Markus. We brought him here.
Do that. Now that he's been involved in the discussion.
Sorry. So Markus, I'm going to say his last name badly. Markus Schirp.
Pretty good attempt.
There was an attempt. An attempt was made. So we brought Markus on because we had this conversation. This conversation was kind of going on. We've hinted at it a couple times on this podcast. Like I've definitely started to kind of bitch and moan about Ruby and like doing security reviews because I've been doing it for about a decade. When I complain, it's because like that's a lot of experience, a lot of years and experience dealing with the headaches of Ruby, and I'm finally like getting to the point where it's just like, what's the point? Like I'm just gonna have more fun reviewing stuff. So that got a little like more and more leaked out. I know Seth talks all the time about like freaking Ruby, but that's like more private conversations. But all this stuff is starting to leak out now. Markus caught wind of it, and Markus has same kind of maybe the same kind of opinion of Ruby having some difficulties, but from a different way with more structured thought. And I wanted him to kind of discuss some of that. His background, like the Mutant, Unparser, Data Mapper 1 and 2, those are projects that Markus, I think now you primarily lead a couple of those, right? Like those.
No, so Data Mapper 1 was basically archived because there was not much to do anymore because open source economy sucks at a certain point. Then Data Mapper 2 was basically, the ideas in Data Mapper 2 went into RM when I was basically absorbed by full-time consulting and the entire Data Mapper team, but Piotr Solnitzer, and he basically took the entire thing and brought it on its own to RM. We still are credited, but what RM is right now is purely his baby. So I can't take any credit for that one because I do not agree to everything, but it's certainly better than the state we had before it. So, but obviously I cannot even judge it because I didn't write anything public in that area. So I can't. I'm not related at all in there. It's more like the foundational libraries which he's still being using and slowly replacing with DryRB are still inspired by stuff we did that time. So I think he wrote his own equalizer, which was derived from the equalizer we made for Data Mapper 2. He took over my inflector library, which was an extracted xlib inflector. And so on and so forth. So most of my Ruby actually right now is abandoned, but mutant. So that's the thing. Yeah. So I'm professionally, I do Haskell right now. I really enjoy it. And Ruby Mutant provides too much value to too many people to just let it die. Let's say it that way.
Yeah.
That's fair, but yeah.
Oh, yeah. I was going to say part of the reason that we wanted Markus on was his experience from the development side in developing against Ruby, right? So I know the big complaint that we have on the security side, especially when we do security or secure code reviews, is just the complexity that goes into it, right? Determining what exactly is happening with Ruby means that reviewing one line of Ruby is like reviewing, everything. Yeah, it's hundreds and hundreds of lines of Java and other things just based on the meta programming and then the libraries that, the interpretation that goes on behind the scenes. It's a difficult prospect to actually tease out vulnerabilities and know what is happening. So dynamic, and we'll talk about this a little bit, but Markus, like the initial discussion that we had on Twitter, or that you and Ken had on Twitter, remind us what it was that why that came about.
I'm not sure anymore. I think it was several discussions.
Yeah, it was a lot of discussion.
And I would argue that it all boils down to, I do not want to run a development process which can only be successful when I rely on just human discipline to not do certain things.
Yeah,
that's the summary of all of this. So when I write a development cycle, I want that there is some kind of a threshold, and then when I'm below the threshold, the system just says no. So when I'm below a certain discipline threshold, but most of the correctness of a Ruby program is only guarded by discipline, by human discipline. Human discipline varies over time. I can be not enough caffeinated. I can have a bad day, whatever. But the language will just eat it, and that's bad because it's so easy to cut corners. And one of my statements, I didn't say this before to Ken, I think so far, is that the average quality you can expect on any piece of code written in a specific language is the average of all the pushback developers get from the language itself. So when you have a language like Ruby, which basically allows you to do everything when it just must parse, basically, the average quality we will expect, because you can write the best code you want, but you will have to deal with the ecosystem, and the ecosystem can ruin everything. And that's the core thing with Ruby. I think Ken and I started the discussion on specific syntactic and semantic structures of Ruby, but it all boils down to the average you experience as a developer is the average quality the language enforces stock, because only a small fraction of people actually have good tests, and only a small fraction of these actually have a lintler, and for a small fraction. So it's just a fractal, and this fractal can just raise the average a little bit, but it will never beat the default pushback a language has. That's my current mental model of the state of any dynamic language.
We go through this with so Seth and I give this like secure code review course where we teach people how to do secure code reviews. But one thing we focus on, just a background real quick, Markus, like security people get thrown pretty much anything, right? Like this happens very frequently in consulting too, where it's like, all right, do we have any, I don't know. Let's use Ruby. Do we have any Ruby on Rails specialists? No. Okay. Well, you got a week or two to kind of brush up on what Ruby and Rails is, and then do this secure code review. That happens, unfortunately, all the time. So anyways, our course is geared at just basically like teaching people, here you're given any code base, any language, whatever, start going. Well, one of the exercises is we actually have people, very simple. We have people sit down and they look at they don't know that it's a devise before action, but that's what it is, right? It's a device. It's actually written to devise. I think it's like authorized user or something like that. But anyways, the reason we have them do that. Oh, sorry about that. So did you hear the before action authorized user bit?
You said at the moment I said you froze, you were unfrozen. So sorry.
Okay. No, yeah. So the authorized user bit, we just say like, tell us what you know about this authorization. Tell us everything you can figure out about this authorization feature, this decorator. So inevitably, most of the class has a very, very difficult time figuring out where that before action comes from. And that's the point. That's the whole point, is like there's inside of when Rails boots up, you know, it looks at its gem files and its dependencies. Everything gets loaded. It takes a little while. Cool. But like there's at no point an easy visibility into where, for like, if I'm just sitting down with this code, where that function's defined. And then once you do find where it's defined, good luck getting somebody who's not super familiar with Ruby to understand that metaprogramming. If you've ever looked at like how Devise does that, like how it's metaprogramming at its finest, it's like super confusing. That doesn't make any sense to anybody when they look at that code. They're like, eval this long, so is this all string? Like, how does this work? Yeah. Right. So now that's somebody who's kind of novice level. I get that, right, with Ruby. But I think that it's unrealistic to expect somebody to sit down and you to think it's okay that person might sit down with this code base and not know that like where that method's defined, it not be clear anywhere where that method's defined. There's no evidence as to where that method's defined. There are things you can do. You can instantiate the controller class. You can do a source location if you know that's even available. Like and assuming you have Rails console available to you, and you can load up all the code.
Assuming even boots in your development environment at that moment.
Right,
yeah.
Right. So if you know all these tricks and you can get it actually running, sure, but like, I think that's
half of the methods they actually depend on database state, and the database state might be different in production, and so on and so forth. Yeah, I know this is fun.
Yeah. The inheritance chain is one thing, but then which part of the inheritance chain is going to be called depending on the dynamic situation. All of these things,
and
like
even the constant scope. So if you have a production application with autoloads, I think this is where our discussion started, because if you have a production application with autoloads, and the application is large enough, you will observe different constant scopes because of the sequence of events which triggered the autoloads, which populates the constant scope differently in a semantic different way. So I've seen large Rails deployments go into substantially different constant scope on nesting which constant is defined where, and so on. And it might not be caught by the code, it might be caught in the code in a bad way, and so on and so forth. So most of my time I spent as a Ruby and Rails consultant is to first, just make it deterministic. So whenever Ruby process boots, it should have the same constant scope. It should have loaded all the code, not just a small fraction of it, because we do not want, when the first time the Google crawler comes along and hits a certain URL, we get a dynamic require, which then in the old days requires mass n through 3 different transitive dependencies, and then your division operator is fucked. So but Ruby at a higher correctness guarantee level is mostly unfucking it. You just spend time to mitigate all these things. You spend time on patching out autoloads. You spend time on preventing evil at runtime, because you want to be sure that the code you actually validated, however you did it, is the same which is in production. So you need to make sure that dynamic modification doesn't happen after a certain point of time. I call this the pivot or boot inflection point. I made multiple names for that in different scenarios. And this is just a giant pain in the ass. So sorry to say it. And and the problem here is Ruby tries. Okay, so also there are 2 levels of metaprogramming. So you can do metaprogramming via just pushing some procs around and calling the define method with a block. That's fine, but you can even just generate source and eval it. So there's even, and the first one is easier to review than the second ones, because if you have dynamic source code generation and eval it back into the runtime, it's much harder to review than if you had just proc-based metaprogramming construction via the reflection APIs. And yeah, so but the discussion started on where Ruby went bad or went wrong, and lots of people like to call out, yes, but there are that many startups with that much market value, and Ruby isn't that bad. But I would just like to turn the question around. So, do you think these companies exist because Ruby or despite Ruby? Because they do not solve the problem of running Ruby in production. That's not the value generator. The value is that GitHub exists and allows me to do easy source code management. So the value is generated via Ruby, not nobody pays GitHub $5 or whatever the current subscription fee is to run a Ruby process which serves me. It's not about the Ruby thing. It's just about the business problem being solved. And if in a certain moment in time you have N Ruby developers available, you just start with them. So it could have easily been Java developers or F# developers, who knows, developers. So I don't. There is correlation, yes, but is there causation? I don't know, and I do not like to be shut down with this argument because we have no indication that the success is because Ruby or despite Ruby.
I have a theory on this, by the way. I've always thought that it's more of the technology choice in the moment of the developers, but really it's the developer culture that really pushes forward a company. What I mean by that is I think a lot of the success of some of these places, it's based on their engineering culture. I could be completely wrong because there's multiple, let's be honest. The success of any company does not lie on just one element, like a great engineering culture. It's a big part, but it's not the only piece. But I do think that you do, like when I come across a group of Ruby developers, I usually feel like I can expect pretty good engineering like backgrounds, pretty good engineering culture. At least that's been my experience. That having been said, I've seen a lot of those same developers move to other languages like Golang. You had mentioned Haskell, Erlang. I've seen like Node, Rust. Yeah, I've seen all of these and these shifts. So I don't know if it's really like necessarily that the language was ever the success so much as the engineering culture. Yeah, that's always been kind of my theory on that. But I think you're seeing a lot of people move away from Ruby, and even at GitHub, while our main product is the monolith, more and more is being broken out of that monolith, and I'm actually reviewing less and less Ruby, thankfully, and. Yeah, I do. It's sort of like when I do a Golang or a Node review, it's very easy to follow. And that's weird because Node used to be a pain, but not so much anymore. But anyways, not to get off on a tangent, but those are like very easy to figure out where things are defined, where they're pulled in at. Just from a review standpoint, it's
when you do code review in Node, do you have to often resort to the equivalent of asking Ruby for the source location for a different method, or?
No.
Nope. Now everything's declared in the same place, and it's easy to go trace back through. There's less. The other thing that you mentioned and you touched on, I think for a moment there, was the fact that like so much happens once your application is booted. Like those dynamic variables that happen at load time and that happen also based on the data being sent to the application. With Ruby, that oftentimes is like far more important than or at least deterministic on how it's going to behave than like looking at just raw source code with no other context and nothing booted up.
Yeah, and just to touch a little bit on it. So when I from Data Mapper 1 disappeared into consulting basically for the last 7 years, we took over a relatively large Rails application, which was basically Spree at that time. It's a very, in my opinion, not very good written open source card. And it has lots of performance problems, a lot of security problems. So and we incrementally refactored that piece. So that was basically the job for 7 years. And we identified that the only way to squeeze out a little bit of being sure that what we do is a good iteration is just to give up any kind of static analysis and just go full dynamic analysis. So just boot the application and ask for its semantics via tests and figure and try to minimize what possibly could be implemented in the code that test didn't ask for. That delta had to become too close to zero. And this had lost lots of, and this needs to be automated because there is no way a human can go through code and verify are all semantics possible in which the code could possibly express asked for in the code, that's important. No human can do this. And the only way we could go there where we went effectively was some form of dynamic analysis, just writing a tool which kills the code and just asks the test to not kill the code, basically. So kill semantics in the code. This is where this entire mutation testing thing started. So we started working with mutation testing on Data Mapper 2, but Data Mapper 2 got canceled out of economic reasons, basically. And then we went into consulting and just applied whatever we wanted to do Data Mapper 2 with in that scenario. And even then, we were not happy. Even then, with full mutation coverage, we were, after we had like 99.999 whatever, we would still be fighting external libraries most. So we would most of the time have to, on each Rails update, go in and just, okay, what kind of core patches they do now? What kind of core patches get loaded late? What kind of third-party libraries might have an auto load which loads mass n? At the time it was still a thing, and so on and so forth. So, and what I'm asking by myself, does a dynamic language inherently lead to the mess Ruby finds itself in from our perspective right now, or not?
That's that's a really good question, because it feels like that's the path that dynamic languages go down, right?
Yes, and I have a thought on why. Because in dynamic languages, the only safe choice for a language maintainer to do is to add syntax. There is nothing there. You can add to the stdlib, which is safe. You can add optional parameters everywhere. You can add optional parameters returned by blocks. You can just make all the signatures wider, but you can never remove anything.
Yep.
Because nobody has the coverage, and there's obviously no type checker, which is a form of coverage, to actually change something. So we still call private class method to set a singleton method on a module as private, just because we cannot change it to private module method or private singleton method. We could only add the new one and declare the old one deprecated and remove it in 30 years. But there is no safe, destructive change path, which is sometimes required in the Ruby language and all dynamic languages. So Java, the JavaScript people played it really safe, because the amount of syntax JavaScript adds in a major release is basically a Ruby minor release. So it's the amount of new syntax we get. And with a dynamic language, you, in my opinion, need to get the syntactic and semantic core right in the beginning, and then, because after that you are stuck. After that, it has a little bit of adoption. Obviously, when only you and your friends are using it, you can change it as much as you want. But if you have a big corpus you need to stay compatible with, the only thing you can do in dynamic languages as a maintainer, and I do not blame the maintainers for this, because they want to make some progress, they want to make everybody's life easier, is to add things. I call dynamic languages add-only languages for that reason.
Yeah. No, I mean, you see the same behavior with Python, like Python 2 to Python 3. Like, I think about it. I mean, there were some breaking changes between those two, but the majority of it was, hey, we're adding new things. Perl as well. Like, just like it kind of spun out of control with Perl 6. So it's the same sort of dynamic issue that you're dealing with. And then like the inherent state of the application, because it is dynamic, it is so exactly what you're saying. It's so difficult to predict what's being pulled in, right? If you've ever even, Ken, I'm thinking about even those Django applications that we load up there, right? That if you're not super descriptive on the third-party libraries that you pull in, all of a sudden, what I run on my machine looks completely different from what you run on your machine. And we pulled from the same master branch. We just happened to start it up 10 minutes apart, right? Or whatever it is. So I don't know how we get away from that outside of, Markus, what you're saying, like having a way to actually disable or delete functionality, delete specifications. But a company, like a lot of the companies I deal with, are not going to, they're never going to choose a language where they think, hey, we're going to write something and we're not going to be able to run it for the next 5 years, right? That's
an interesting point. And I'm past the point where I say, okay, so there shouldn't be dynamic languages, but there should be, taking a dynamic language is a form of voluntary taking on tech debt, and tech debt is fine as long as you have a payment plan. And I see as a consultant, sometimes with a security focus, sometimes with stuff is burning, please help us. I see that the payment plan is completely ignored. It's like, so if you choose Ruby, you need to think about, okay, so I choose a language with it's basically add-only evolution, with everything can change everything. So then my test pattern, my application boot pattern, and so on needs to accommodate for this. But I don't see these kinds of thoughts right now. I see them partially, And I really hope that Ruby 3.0 delivers a native deep freeze feature, which would be really helpful because we can just put an end to certain kind of ad hoc mutation. I actually co-maintain a deep freeze library for Ruby right now, which I use in production. But it would be far better to have it built into the language because you can, in worst case, if you want to defeeze a deep freezer, you just redefine the freeze method. So then the deep freezing will not happen.
So to freeze, are you calling like a freeze method on certain like methods, or like what do you how do you implement?
There is a public one. There is a public one. It's called it's a gem. It's called ICE9, which it's basically a generic algorithm to discover all objects which are referenced from a specific object. It would go through instance variables, through items in the array, through hashes, and just calls freeze on all of them. And and has a cycle protection to not go wild. And that's the one object. But in certain mature Rails applications I deploy, I actually patch out evil after I know the app should be loaded, and then find it crashed in production because then I just need to force the load earlier. And so that's the end game, but it takes lots of time to reach it. And each update is really fun because there are more dynamic call sites. So we patch out define method, I patch out all this stuff over time. So ICE9 is just for data structures. So it's not that library. I've never found the time and energy to write a public of these global stop meter programming from now method, which patches all of these APIs out of Ruby. There are some gems already. I think one is from Postmodern. He has a gem which disables eval after a certain point, which is a great thing to do. Just removes the method from the kernel namespace.
Say from Postmodern.
Postmodern, I think I'm not sure. I do not use that one.
I think it's because I'm familiar with Postmodern_3. Basically, as long as I've been doing Ruby, I've been following Postmodern's work. Yeah, really. I'm going to post. Yeah, sorry.
For some reason, Google doesn't want to talk to me, so I can't find anything for the moment.
It does that. It knows you're on a podcast. That's what happens.
That's what happens.
Yeah. The interesting take, and the question that I have for both of you, right, in this situation where you're dealing with engineers and you're trying to build, Ken, I mean, I don't know how involved you get on the Ruby library and deployment side of the monolith, but at the same time, like, how do you ensure that what it is that's being developed is what's being represented to clients and is being used in production, right? I mean, that's the real question that I have, because from a security perspective, that seems like a huge gap for me. Yeah,
you just reduce the risk of delta. You can never be sure. So that's the first thing to realize. You will never be sure that with these kinds of, actually with any language, but the gap is much higher in dynamic languages. You will never be sure that what you tested and verified is actually the behavior in production. The only thing you can do is a series of steps to reduce the risk of a significant delta.
Yeah.
And that's quite invasive. And lots of Ruby people would really dislike stock to interact with the code bases I nailed down like that. But it's the only way to actually be sure that what I tested ended up in production.
I mean, to your point, we find bugs. I mean, just within the last 48 hours, there was a bug. And I'm not talking about security bugs even. I'm talking about just like
semantic bugs.
Yeah, just exactly. And some of these are around for a while, and it takes the right condition for them to actually
manifest,
be caught, to manifest and then be caught. Exactly. So, like it's just to your point, like I see that probably every 4 or 5 months on average, there will be some bug where it's like, how did that never come up before?
Let's talk about semantics and units here. When you write a piece of code in Ruby, the only canonical way to guard its semantics, what it should do, is you write a test for it. The problem is that a traditional TDD cycle, let's assume you do it. Let's assume you adhere strict to the core of TDD. You start to write a red test. Then you write the minimum amount of code to get it green. And then you start to write another red test. And the assumption is that all the code you've written is covered by the tests. The problem is literally nothing in a traditional TDD cycle guarantees that you only implemented that green test.
Yep.
And
So,
that's
yeah.
where mutation testing comes in. Mutation
Yeah,
testing is able to guarantee, sorry for interrupting you,
No,
to
you're fine.
heuristically guarantee that there is no extra semantics but in the test. It's
Yeah.
much way to specify the test. That's
You're speaking to Seth's language. He loves testing, so that's why
you are, and I'm interested to talk about your mutant library and like what it is that you're doing there, because it sounds like that's where it came from. But this is where, like, I've been talking with like the local OWASP chapter about testing recently, specifically around this functionality, because the QA tests and the integration tests, the functional tests that we normally do, don't cover edge cases, right?
Exactly, and that's when you do TDD, you are supposed to write some form of unit test, and the unit should be as fine-grained as possible. And with Ruby, I actually resorted to write a test per public method per object. That's my default at this point. I gave up to just assume that some more higher level tests can do it. Sometimes I declare a specific class as private inside a namespace, and I only test the very public method, which is supposed to have a stable interface. I can point to some examples later in some of the public code I wrote. And under that assumption, by definition, if you do TDD against such a public method which forms a unit that could be tested, and you use a form of mutation testing which guarantees that, at least statistically, because no mutation testing tools are fairly dumb, they just run a relatively unsophisticated heuristic to reduce semantics and try to get the test to admit that this specific thing they reduced is not covered, then you have two options. You can either not write the code that way and just use a simpler form. We can go into various syntactic constructs later. Or you just say, oh, that's a really important thing my code does, which is actually not in the test, so I just add the test. And this is only if you do this very partially ridiculous cycle, because sometimes you need to write a very boring test, but the language has no other constraints. There's no type system. There is no universal quantifications. There are no type classes where you can say something for all A and B, this function does X. Semantic X in that case. As long as you do not have this kind of, I call it transient reasoning. So types are, you do not need examples. You can actually make for all examples. And if you choose the right types, they eliminate lots of boring tests. That's the reason I was drawn to Haskell. Basically, I maxed out my amount of example by specification in Ruby. I was like, I do not want to write boring tests anymore. And then when you have a strong type system, they eliminate like 90% of it. And now I'm at the point in Haskell where I'm like, okay, I would really like a mutation testing engine. So because it must be much more fun, because the type checker is much faster than test, which means if I write a mutation testing engine, large parts of the mutations will come back by the type test, will come back as dead by the type checker already, and only a small fraction then hits my very fast test, because Haskell obviously executes much faster than Ruby. So, yeah. And that's my. Sorry to go totally off the rails. We were talking about Ruby and testing. So I was spun out of control here.
Yeah.
Okay. So back to Ruby and testing and on how to, that's my payment plan for dynamic languages. Okay. So I say, okay, I'm on a dynamic language. The smallest unit I control is probably a public method in a specific object I write code for. And I write tests for all these public methods, which I assume to cover all semantics in the call graph of that public method. I do not test my dependencies because it would be ridiculous. And I just assume Active Record does, for example, I use the Active Record API in my object, does the right thing. And I assume that if I change the code under test automatically with changes which strictly reduce semantics, I never do something new. I do not add a log statement. I just delete statements. I delete methods in a chain. I delete an argument. I delete the left side of a plus b. I delete the a, let the b, and so on and so forth. I assume that if my tests are covering, because tests are just examples, they're not types. So let's say if my test could even have a remote chance to actually specify my code, all these semantic reductions should be caught by the test suite. And if not, I have a giant hole I need to fix. And it will only get me to like 95% of certainty, but it's much better than standard Ruby where you just do TDD. Yeah, that's my current go-to approach to actually pay the tech debt of using a dynamic language.
And that's an interesting, I mean, it's a different take to come at it, right? Like, because I always come at it from kind of the security testing perspective. Right?
I think it boils down in the end and there's no difference anymore.
Oh, yeah, it really does. And that's what I'm thinking about is, hey, I start to think about like different payloads that we can throw at functions, at those public interfaces, and just to see how they respond. But the mutation testing that you're doing is kind of more of the full coverage as far as you can get.
What is a security bug? A security bug could be, in the sense of TDD and extra semantics, be defined by an unintended protocol formed by extra semantics added during a TDD cycle, which compounds, accumulates, and then forms a protocol which allows some form of exploitation. Yes. Because exploitation is nothing more than unintended semantics being triggerable by some endpoint. So and if you constantly remove the semantic delta, the chance of finding something in a high-level code review is lowered. It's not zero, but I take 90%, killing 90% of all sources of small additions in semantics nobody asked for. Nobody, in that case, is a test. If you do this constantly over the entire development cycle, the chance that a focused review for security finds something is far lower, and actually the tests become meaningful because already the test had passed the mutation testing system, so I can actually check the tests on what the system is doing. I do not have to dynamically trace as much anymore.
Yeah.
It's not so much. Let's say it's that way. You see a function definition, def, foo, bar, and there is a default argument for bar. So you see this as a security tester. So then you need to ask yourself, okay, so is this default ever used? And is this default ever used without its default, with just a value other than the default value? So could I just remove the default argument? No. This is one of the core things when I introduce Mutation to a new code base. Is typically people do not specify a test case where the default actually is provided or is not provided, or the default is provided with a different value than the default value would be. And then if you use mutation testing during such a development cycle to make such a method, you have a full specification of that method in the tests. So okay, the author of that piece of code actually has a full specification of the default argument. I can look at it fine. It's not like totally fluent through the entire code base anymore. It removes one level of research for you as a security minded reviewer. And also as a code reviewer, I do lots of code reviews. It's far easier for me to read a 100-line patch and know, okay, so I know what the mutation testing engine would do. And I know the mutation testing engine can do nothing to this code. This removes lots of manual changes I could do through the code base. Like, okay, so we have a chain foo bar bars. Can I remove the bar? No, I can't, because the mutation testing engine did it for me already. I don't have to think about that rabbit hole right now. I can focus on the high level thing. So it's more about, as I said initially, so we need to do development cycles in a way that the effect of human discipline is minimized. It will never be zero, because at a certain point, if it would be zero, you could just press a button and development would happen. And but I want to spend the limited amount of human discipline I have during a day on something where the human mind is actually suited for. And it's not suited for to test various small hypotheses of, is this bar or is this default method, and so on and so forth. So these small things can be automatically tested, and then I can focus on whatever is left, and there is enough left. There's enough there. I can think about encodings. I can think about, was this method, this is a string which is supposed to hold an address, and I'm about to pass it to a different system. Is this different system correctly encoding it, and so on? I can do all that instead of focusing on, okay, is this if ever triggered? Is this else ever triggered? And removing all these low-level questions from my head allows me to spend a limited amount of discipline far more efficiently. And this is my payment plan for Ruby. Yeah. So this is what I ended up with after doing that for 7 years in an environment where mistakes were very punishing, let's say.
Yes. So you want to start a payment plan for Python then? Is that what you want? That's never mind.
No, I don't have a mutation testing engine for Python. I've written Python like last time 10 years ago. So I've never written tooling for Python, so I wouldn't know on how to do it. So this is just one instance of a possible payment plan. I'm very sure that other people can come up with different solutions on how to deal with the Ruby problem. So my current payment plan is every iteration, every code I touch, I make sure that all of these semantic reduction mutations are covered, to make sure they do the chance of forming unintended protocols lowers over time. That's my payment plan for Ruby.
So my question with that is, like, let's take your example of, you have a method that's defined, we'll call it foobar, and it takes before you said one argument, like So let's say it takes 2 or even 3 arguments. Are you writing
default arguments or with defaults or without defaults?
Defaults, all just default.
All
are you?
Defaults. Okay.
Yeah, like they have a default, but they can be omitted like every.
Okay.
Like every Ruby with the predefined arguments can be. So the question I have is: are you saying that with mutation testing that you having to write, say, like, let's say you had to write 2 separate tests. I don't know if that's the case. I don't know if you need to write 2 separate tests, like one test that says there's no argument provided and one that's like some arguments provided. Are you writing like it's two questions really.
The test is unjob defined. The test needs to have a call site where if the argument would not be provided, it would make a difference to the test outcome if the argument were removed from the code. It's a very long sentence and I probably got it wrong. It's much easier to write it down. And
I guess
go
ahead.
So the number of tests is not the metric here. It's the number of semantics the test observe. You could actually kill, in theory, write 1 test for an entire Rails application if it touches all semantics. So this is just because how do you count a test? Is it the number of asserts? Sometimes is it the number of groups? So I do not want to go into that territory until we have a definition we can all agree on. Let's just argue about what kinds of semantics the tests ask to be observed in the code. So let's say we test an argument, we test a method with 3 optional arguments. Then the mutation testing engine would kill all arguments and then run your tests. Your test will pass. Very likely you never provide an argument which makes a difference in your test. And then it's up to you, the test also to actually.
My question.
We are slightly.
Go ahead. Sorry. Go ahead.
Okay. So then it's up to you to provide to make your test notice that if the default you make a test notice, which is very likely, okay, now I pass in arguments because to make sure that the engine cannot take it out, because then I get a number of arguments error. But then the funny thing is most developers, including me, because we are tired, it's just a stupid test, would pass in the default argument. And then it's not a specification. You need to pass in something else than the default, and only then it tells the mutation testing engine that the default actually matters, and actually that you can specify something else, and you intend to specify something else. And what happens is typically with using mutation testing, you do not write more tests, you write far less code, because you. That's the core thing. Let's talk about Ruby fetch. Let's hash square bracket operator. You have a map and you know the key exists. So what do? You write the square bracket operator done. Problem, there is in 3 years or 3 iteration cycles down the iteration chain, you for some reason production hits a key which doesn't exist. But everybody assumed it exists, so the nil gets propagated somewhere and it blows up 20 lines in the call stack somewhere else. It's a pain in the ass.
Right.
So what
key not found.
Yeah, whatever.
Yeah.
What Mutant does is it forces you to use hash fetch unless you actually have a case where you want to read the default hash, the default return value of the square bracket operator. So there's by default it's nil.
Cool. If it's not, it doesn't break.
Yes. So what Mutant will do is if you ever use the hash fetch, if you're a hash square bracket operator, it will force you to use fetch unless you actually have a test which shows you that you are correctly handling the nil, which could just be to not crash and just return. It's very easy to kill that one, but it just removes implicit semantics all the time. So because from going from square bracket operator to fetch, it gives you a key error instead of a silent nil, which in my mind is less semantics because you leave the value space, so you go into exception space. And the same is for providing an argument to a function. So let's say you have a call site for these. We just made an example for these 3 optional parameters. Let's say you have a call site and you specify a call site for a function which takes 3 optional arguments. Mutation testing will take all arguments out and run the test for your function which calls that function. And if it still comes back green, it tells you something. It tells you something that you didn't observe anything, basically. You just observed the default behavior of that method. You never specified a case where changing these default arguments actually makes a difference. And if you then have the development practice in your team to say, okay, we only accept code if it passes mutation testing over time, these kinds of problems disappear because people learn like, okay, an optional argument is basically just a hidden if. So maybe we should reduce the need for these things, and do not write these giant APIs which take an array and maybe it's a hash passed, and the implementation just some sensing. Maybe it's as a block, and with the block returns a hash, and all this semantic clusterfuck. These APIs are just the result of a dynamic language also because they are add only. It's much easier to for the look at kernel system where you spawn processes. It's like 500 different forms, and they didn't exist from the beginning of time. They were added over time. They were like, okay, so initially it was maybe just a string, it went through bin as h, and then we were like, but it's unsafe, and okay, so maybe we add an escaping system, shellbots, or however it's called. It's still bad. Maybe we want to go to execve. Okay, so then if you pass an array, and it's still the same API, but lots of optional behavior stashed inside these APIs. And I wanted for my teams to make it more painful to ever define these interfaces. So that's the other pushback here. You constrain yourself in writing more simple code in this payment plan for Ruby.
Right, but your payment plan, basically the mutation testing, that's sort of that you're not writing n exponentially amount of tests depending on how that method.
You just need one counterexample. What typically happens is let's go for something fun like addition. Let's assume there's no addition in the Ruby core library, and for some reason we could still add. So you write a function add a plus b, and you say the implementation is a plus b, and then you test that one. And a typical case is, okay, I test 1 plus 0. It should still be 1. The mutation testing engine will tell you, hey, if I take out the b in the implementation, this test still passes. So maybe provide me some input which tells me that b is actually evaluated in some kind of semantic form. So it's not typical an exponential blow up. It's more linear. So if you do test constrained by mutation testing, is typically the number of branches, the number of tests you write in a function. That's the typical thing. So then you sometimes it's a little bit more hairy, and you can go with some. Writing good tests is also a form. Writing an art form, writing deduplicates is also an art form, which means you can go with included examples, you can go with better test oracles, and so on and so forth. So there's lots to do. For example, I was talking about a case where I do not have a specification for all public methods because these public methods are in so-called private objects. The unparser I wrote. The unparser takes AST to concrete syntax under the constraint. If you were to pass this concrete syntax again, you get the same AST.
Okay, I see what you mean.
And
so
that's
node structure breakdown of an AST, they're the same.
Takes it to concrete syntax, but under the constraint, if you pass it again, you get the same AST. So you do not get the same code because there's many more concrete syntax for a given S node than the other way around. And that thing has one public method. It's unparser.unparse. And there is a giant swat of private classes for each node type inside, writing to the buffer and all this stuff. And this entire generator is specified through this unparse method, and all mutations are killed via that one. So you need to with that approach, you always need to define what's my public interface. So the various small emitter classes are not my public interface. And I do not have specs for them, but the mutation testing engines, good ones, are actually capable to figure that out. So they see, okay, so there is unparser emitter send. This is a class name. I will have a mutation in that one in a private method called dispatch. Okay, so let's look at the specs. What specs do we have? Is there a spec for private unparser emitter send dispatch? No, there is none. Okay, let's go one scope up. Is there a one for unparser emitter send? No. Unparser emitter? No. Unparser? Yes. And then that one is supposed to catch the mutations.
Oh, interesting. So it's using the power of the dynamic language to test the dynamic language is basically kind of what it sounds like.
So the implementation is very funny at points. So also Mutant can test itself and makes a dynamic in-memory copy to then execute from the copy against its own test, against its normal namespace, all this stuff. So, but it's not, so it's more like RSpec gives me a little bit of metadata where I can select the correct tests for. And if I do not write a test for a private method, then it would just scope up. It's just like IP routing. You find the longest prefix match, and then you go with it.
Okay.
And but the what I really want to drive home here is it's about not leaving these small breadcrumbs of extra semantics all over your code. Yeah. And always need a counterexample when you want to do something complex. Example, you want to have you have an if you have a ternary operation. It's basically just an obfuscated, just another concrete syntax for an if branch, and you have something which gets evaluated on when the condition is true, something which is evaluated when the condition is false, and Mutation will just take out one of these faults. It will line coverage has told you 100% already, but Mutation will just take out the computational branch on when the condition is false and ask you, can we remove this? Yeah, every alive mutation is basically just a flag by an expert code reviewer. Why don't we remove this? And in most cases, it's just like, oh yes, actually it was redundant because I actually meant to use the fetch operator after a fetch operation on a hash after I learned what it actually means. That it's much better to blow up early if it's not found, unless the code bus explicitly expects the default value of a hash to be returned, and so on and so forth. So it's more about each of these automatically generated flags is a question, why don't we do this simpler thing?
Yeah.
And
I think that
then you can reply to the engine, okay, actually good idea. You added the code to do the simplest thing, the engine will shut up because there is nothing more it can do. But sometimes it's like, hey, that's actually important. We actually need to handle unknown keys in that hash. Let's write a test for that. And if you iterate this game forward, it results in code which is far less susceptible to the kinds of problems you have as reviewers on a dynamic language.
Yeah.
I mean, one of the things I was concerned about but I'm not anymore, was, the biggest complaints are tests take too long, or I have to write too many tests. But also sometimes writing too many tests means there's this doesn't seem like it's an and those would be the major roadblocks I would see to being able to test in this way and paying down technical debt in this way. But clearly that's not really a roadblock. Because we have to wrap up here soon, I did want to just so if you just kind of summarize sort of your thoughts. I mean, I think you've talked quite a bit in terms of details, but if you wanted to summarize for folks, like your sort of I guess thoughts on Ruby, and where you see it possibly going. I mean, you've talked a lot about paying down technical debt and ways to go about that via implementation details, but I guess I'll just ask you, do you plan on continuing to use Ruby? And do you think, again, sort of any summarized thoughts on other people continuing with the Ruby ecosystem?
I think that the technological choice you have when starting a system is bounded by many things. The language you're choosing, the current skill level of the developers you have access to, and this all plays a role. From where I am, I wouldn't start greenfield with Ruby ever, but I will still touch Ruby because there are high value code bases out there which need help and need incremental improvement and need to solve fundamental issues. So that's, I personally wouldn't touch Ruby if it's new, but I would totally fine to touch Ruby for clients which need help. So I cannot make a universal statement for anyone out there because I do not know where they are. So I can only tell how I navigate from where I am. Yeah. And this can be an example for their navigation.
Yeah. And where do you think that the Ruby ecosystem is headed? I mean, personal, professional thoughts.
So I have high hopes for gradual typing, and I have high hopes for native deep frozen objects, which could tidy up a lot. But I don't have high hopes that it delivers. So I have high hopes for the concept, but not high hope for delivery. And I don't blame. I love the Ruby maintainers; they're doing a good job. But it's more like they are working on dynamic language, and this has inherent constraints. So there's and that's basically I do admire them that they try regardless, but I wouldn't put my money on it. Let's say that could be a good summary.
Yeah.
Nice. Yeah, you've given, honestly, there's so much to unravel from this conversation.
It's a little bit unstructured. So I'm not used to do this in verbal language in this format. So because I was 10 years remote before it was cool, I was just typing all day. It's all like it's much easier. Lots of semantic constructs we talked about is much easier if we had some kind of Markdown enhanced chat window
or a whiteboard or something like that. But
exactly, yeah. Actually, code. So that's what I wanted to drive home. Everybody who's interested to get a demo on these kinds of Ruby things, I'm happy to do it. Just hit me up on Twitter. I love talking about this.
Yeah, so I did put your Twitter account up there for folks to reach out. I mean, honestly, I just because I'd mentioned earlier we had discussed privately some of these things. Like, yeah,
but there's more to it. There's more to it. So making these mutation operators let my team realize that there is an axiomatic way of making decisions. It's not like I want to get rid of, so we have a technical argument and technical weight wins because the seniority of the oldest guy in the room and he is always doing like that. No, so you can actually break down good software development from a core axiom, which is basically let's go with choose a simple thing is most powerful thing you can do in that moment. And that's a good engineering principle. Example: if you have a conditional branch on a Boolean, then it's an if. If you have a conditional branch with more possibilities for the branch points, then it's probably a case. So never use a case statement on a Boolean because this is the case statement has more powerful semantics, and that's what I'm trying to drive home. It's not arbitrary. So or craft, oftentimes it looks like everybody just has his style and so on. I would argue this actually only exists in a small portion, and we tend to invoke style where we're out of arguments, and I think there is more to it.
Yeah, I think I've heard Stefan say multiple times, never use a case class for a Boolean.
Yeah. Sorry,
Stefan's like our resident language theory guy. He's on here quite a bit. I honestly should have pulled him in. Well, we shouldn't have, because then this conversation would be a 4-hour conversation. So it would have been. So it would have been.
It's still very unstructured. I would love to find a way to finalize this. So I think our craft of software development is still in its absolute infancy. And if I look at the medical professions, they basically know unless it's a double-blind study is bullshit. And we don't have this global invariance yet. And we should actually, and we should be able to eliminate lots of discussions, because if you as a team end up in agreeing to shared axioms, lots of discussions just disappear because everybody would just follow the same decision passed down. There's an entire other discussion to have on how to work together in a software team on that basis.
Yeah. There is. I mean, the craft of software engineering is not. I mean, it's new, right? It's still incredibly new, and there's no defined way to do it, or there's no defined set of axioms that we're building towards or that we're using to do anything. And then we change the language, we change the framework, we use dynamic versus compiled.
Some of these things are transient. So some of these things are universally true. So when you have a construct, when you use a construct which is powerful to do something a less powerful construct could do, conceptually, regardless of what level, you can go syntactic, semantic, on which keyword you choose. That's a good one. It's one which is easy to agree to, but it's very hard to adhere to because everybody loves the double quote versus single quote debate. Yeah, it's just. But if you actually subject yourself to such an axiom, your opinion doesn't matter anymore. It's a little bit of it's a very humbling experience, because then you choose single quotes unless you use interpolation. Because if you use double quotes without any kind of interpolation, it's using a more powerful primitive for something which could have a less powerful primitive. And if you do this, there is so much more than this stupid syntactic construct. We deal with so many more languages, and I propose that one as a solution to lots of bike shedding.
Yeah. Yeah. Well, absolutely. So, Markus, we want to thank you for your time, right? We obviously put your Twitter handle up there.
Thank you.
It sounds like this conversation will need to continue on, because there's a lot more to unpack, like Ken was saying, that we definitely want to, there's a lot to talk about as far as dynamic languages and like axioms, like you're saying, and how we actually go about this craft. But then I do also want at some point to talk further about, mutation testing versus security testing, like, how it subsumes that, But how we take this
ever. It's just enhances the ability of a security-minded person to do it efficiently. It's not never will be replaced. You always, so far, I don't see any way to remove the human from the process. I can only. It's just a bicycle for your brain. It's just like lots of small experiments already done. Okay, I can focus on something high level.
And that's just it, right? Like if we can focus more on the business logic side of things and exactly what you're saying, translations between systems where humans are good at it, right? We'll find those higher level vulnerabilities that actually make.
You have time to find the exponent change and not being drowned and chasing nils around.
Exactly. Cool. Well, I know that Ken's got another meeting that's coming up here pretty quick.
Sorry for dragging this out. You wanted to wrap up earlier, and I was just rambling again. Sorry.
No. This was it was awesome. It was great. Like we got. I mean, like I said, there was so much. I actually am going to go back and rewatch this episode because there's a lot to unravel. And it got me thinking quite a bit. I think there's some things Seth and I can take away from this as well, from as security people about security testing. And anyways, there's some ideas that you actually spawned from this. So
feel free to reach out. I'm very happy to also actually show it in code, which is much easier than just to talk about it. So whenever you want to, or anybody else, just reach out. I'm really happy to have a chance to explain it, because each time I have a chance to explain it, I get better in actually understanding what I'm explaining. So,
well, we could always have a part 2, and I think it'd be awesome to have also Stefan involved in that as well.
Interesting. But you need to make sure that I do not go off the rails all the time. So
that's okay. Stefan can fight back. Yeah. Cool. All right. Well, thanks everybody for joining. We'll catch everybody next week, and otherwise reach out, join the conversation on Twitter and in Slack, and let us know if there's anything else you want to talk about. But Markus, once again, we appreciate your time and appreciate everybody listening.
It was really interesting.
Yep. Thanks, everybody.
Bye-bye.
Thank you. Bye.